vacation, counting every crater on the moon, roaming like the only rider high up on the...
In maritime radio communications, analog speech transmission systems in the MF, HF and VHF frequency range with amplitude modulation of the carrier signal have been used for a long time. Digital communication systems are increasingly being implemented in recent times. By converting sound using a microphone into an electrical signal, that signal is analog in nature and needs to be digitized. Here we will see how an analog signal is digitized. For voice communication, the frequency band from 0 to 4 kHz is used in telephony and all other systems. Frequencies higher than 4 kHz are attenuated by filters because they take up too much valuable frequency space in transmission, and have very little effect on intelligibility in voice communication. Digitization of an analog signal takes place in three processes: sampling, quantization, and coding. Analog signal sampling. When sampling an analog signal, the analog to digital converter measures the voltage level of the analog signal at certain moments, and based on the measured voltage, will generate a combination of logical zeros and ones that the radio device will send instead of the read voltage. How often the AD converter samples the analog signal depends on the highest frequency of the signal being digitized. The rule is that this speed should be at least twice the highest frequency of the analog signal. Since the highest frequency of voice radio communications is 4 kHz, it is necessary to take 8,000 samples in 1 second. In the time between two samples, the AD converter produces a combination of 8 bits based on the voltage it measured. Therefore, each voltage has its own unique bit combination that is generated every time that voltage is measured. These combinations of logical bits are called codes, and associating codes with individual voltages is called encoding. Given that with an analog signal there are infinitely many different voltage values between two voltage values, it is necessary to determine which voltages will receive their combination. This process is called quantization. Voltage value cannot get its own code, because there are an infinite number of these values and a limited number of codes. Codes are assigned only to certain voltage values. All other voltages are rounded to those values that received the codes. For example, voltages 5.20 volts and 5.30 volts have their own code, and voltage 5.24 volts does not have its own code. In that case, the voltage of 5.24 volts receives the code from the first closest coded value, which in this case is 5.20 volts. From then on, until the reproduction of the analog voltage from the received codes at the digital-to-analog converter on the receiving side, that value will be 5.20 volts. The information that it is actually more precisely about 5.24 volts is permanently lost, because the DA converter cannot possibly know what the voltage value is rounded to 5.20 volts. The DA converter simply received a code from a voltage of 5.20 volts, and it produces 5.20 volts. Of course, in this procedure, the quality of the transmitted signal is impaired. This deterioration in quality can be significantly mitigated by increasing the number of codes assigned to individual voltages. If a greater number of voltages get their code, then the voltage roundings are smaller, and with that the quality of the transmitted signal is better. In order to obtain a larger number of codes, it is necessary to increase the number of bits that each code consists of. The relation between the number of bits and the number of combinations is. This, on the other hand, requires a higher digital signal transmission speed expressed in kbs. When assigning codes to individual values of an analog signal, it is necessary to take into account the nature of human hearing. The human ear is most sensitive to quieter sounds that produce small voltage values at the microphone output. That is why these voltages need to be coded more finely. This means that the intervals between the voltages that need to get their code are smaller. With stronger signals, the sensitivity of the ear is lower, so the gaps between coded voltage values can be larger.